Welcome to Ask and Learn.
All right, so for part A, we are given the equation for the hydrolysis of ATP, and we are given that its delta G is 30.5 kilojoules. So as always, we're going to use our equation here, delta G equals RT ln K, and we're just going to plug in values. Again, always know that R is 8.34, or 8.314, excuse me, joules per Kelvin mole. And because this is in joules, we need to change our delta G into joules. So, by multiplying by 1,000 to get joules, we would get 30,500 joules. So now let's just plug that into our equation. So 30,500 joules equals negative 8.314 times 200. Whoops. Whoa. My mouse is not working today. Times 298 Kelvin times ln K. So if you multiply these together and then divide this by that value, and then you can take E to whatever number you get, you will find K. So if you want to take a minute and do those calculations, you should get a K of 1.38 times 10 to the 5th. Perfect. All right, so the next part asks us to find the delta G of reaction for the metabolism of glucose. So we're given the reaction, and we're going to use this formula, products minus reactants. I think it's always helpful to write out kind of a little skeleton, and then you can just plug in values where you need to go. So the products we have, we're going to need the delta G of CO2 plus the delta G of H2O minus the delta G of O2 plus the delta G of glucose. Remember, whenever there are coefficients in the reaction, you need to put them in this equation as well. So you're going to have 6 times the delta G of CO2 plus 6 times the delta G of H2O and 6 times the delta G of O2. It's very important to remember that. So you can find the delta G of reactions most likely in your textbook. You can also Google them, but I have provided them right here. So from here, it's just a plug and chug. So you're going to put this value here. We'll substitute these values there, that value there, and this value there. And that should come out to be a delta G of reaction of 2,879 kilojoules. Great, moving on to C. It's asking you for how many molecules of ATP can be produced by metabolism of 1 mole of glucose. So the best way to think about this is you want to get 1 mole of ATP, or I should just say you want to have, let me go back here, sorry, moles of ATP over moles of glucose. And we can do this using our delta G's. So we know our delta G for ATP given in the problem is negative 30.5. So if we multiply that by our delta G, the delta G we just calculated for the metabolism of glucose right up here, knowing that we need to cancel out this kilojoules on the bottom, so we're going to put 2,879 kilojoules up here per 1 mole of glucose. This will come out to give you 94.4 moles ATP for every 1 glucose. So problems like these, it's always best to think about what you already know. So we knew the 2 delta Gs, and then look at the units to see what you can cancel out in order to get the units that you want your final answer to be in. All right, so D, the percent yield, again, this is super easy. So we're going to use our formula here, actual over theoretical times 100%. So the actual is what we actually get in real life. So they give this to us. They say that it is 36. So we can say 36. And let me see. They put, 36 moles. So 36 moles. And the theoretical is what we just calculated using our delta G's. So we're going to plug that number in over 94.4 moles times 100%. And that is going to give you 38.1%.